Welcome everyone to Code Therapy here on our live channel session 832. Live here on YouTube. I slightly renamed the channel because obviously we are doing code therapy here, right? Feeling like some psychiatric stuff for private sessions with depression and the state of open source or software. So in this vlog, the good, the bad and the ugly. The good news is, so the other live stream yesterday, so we took a look, shouted out LLVM, Clang and Family Update 16, and I'm somewhat positively, starting with the good, positively surprised that LLVM Clang stuff mostly builds, like, and even with Mesa and mostly with Rust. That is kind of amazing, right? That is always the good thing. That is always the thing, right? You have some moment of like, hey, stuff is amazing, free as in beer and open source release, and it even mostly works. Mostly with like, yes, some packages needs to be slightly built differently with CMake modules, and also Vasi libcxx didn't find its headers. It's also like unused CMake options and stuff, like a recurring theme, but aside from that, hey, otherwise it's actually cross-compiling as far as I can see and mostly works. It's done with Rust. So that is a good part. Of course, and so usually there is more incompatibility. So probably the API, what I called it the other day, API didn't change that much. Of all the changes here of IR and API. And the bad news is it doesn't build with pre-yesterday's Rust. It builds with latest Rust 168, but latest Rust 168 is a major disappointment, I have to say. And that is always the good, the bad and the ugly, right? In a way it is good that they changed the API stuff already. And as I mentioned, they always change stuff. Also, I just clicked here some random wrong. Doing some scratch. Yeah, Rust long kinda. And the problem is the new release of Rust totally fails. And I spent so much time, the recurring subscribers, members and stuff know that already. It took me probably in the meantime weeks, maybe a month of 160 hours or so in total, easily over the last 3 years, to integrate Rust in our amazing Linux distribution. And then it breaks, right? So it actually does build, but then it doesn't bootstrap in a complete way so that stuff would build, right? So either the cross-compiler builds, but then building a Canadian cross-compiler for the target system fails with not finding STD, as does Firefox, so there is something more majorly wrong. There is actually a Rust, actually did say, last night I noticed there is, 68.1, and that is the frustrating stuff, right? The only constant is change and regressions. So is that released? Hey, it's released. Also, yeah, so am I the only one who says it's broken? It's like, no, they had to put out an emergency.1 release. Because it probably contains CI builds on Windows, no longer enabled LTO for Rust code, leads to miscompilation. And it's like, yeah, Rust, the safe language, they, after a decade, spin out a release. Yes, it cannot happen to everyone, certainly to me, of all few people projects here, releasing broken stuff. But yeah, the safe language to save all of humankind and IT and computer science, yeah, was quite broken. And whether that fixes the regressions, I think I see independent regressions. I have not yet diffed that. I probably should diff 167.2 or whatever that was, and see how embarrassingly massive the changes are. So yeah, that does not build. So I reverted that, right? So being a good open source and release maintainer, open source citizen, I reverted that in trunk. As I did because our AI bot data partially updated some LLVM packages, not LLVM and Clang, but some libstd, CXX and stuff. So I reverted that obviously, and I also reverted the Rust update until when I realized it doesn't build. And it's not even the only regression. I have other regression that it's a regression for some month already, because some quarter, like in October or so, actually I should bisect that, but yeah, good luck bisecting 6-minute build of, is it 6 minute? 6 minute or so on an just Ryzen 7950X. It's like, yeah, one week later or so. Because what happens is we ideally would want to build cargo among the Rust bootstrap, and that doesn't work anymore. I only noticed that by accident as well. Like you build stuff and stuff doesn't build until you realize, wait, it's not the latest cargo version. So far so good, right? It's like LVM mostly good, Rust C somewhat broken. Sure, you can, and pro tip, you don't always need to run the latest and greatest, right? Sure, I run a Linux distribution, I try to be, and like someone needs to test it, right? If nobody, you see this here, one Rust 168, if nobody tests this shit, then it's broken, right? Previous video, moment channel, hashtag perfect code, and unit testing, right? Of other YouTubers thinking you don't need perfect codes. Like, yeah, if you don't have perfect codes, then it's broken and it's not tested. The really annoying thing, like the ugly, is the latest LVM also breaks the previous version. So what I reverted that here to Rust. That's already, so Rust 167. And by the way, because we become even more professional, right? And dedication and having actually well-working Linux distribution, I tagged that, right? So last, I said this before, we want to more continuously spin stuff and so on. So I tagged, I will probably now, like every month, I try probably every month to tag T2 in a relatively non-good state, which was last night with the last LVM version and Rust reverted. And that should be a relatively good state. I will, however, so this text, we will not, for all text, we will not have ISO releases, right? I will, as I said in the other video, I will try ISO, like all 30 plus architecture ISO releases, like every 6 months approximately. I said previously, it's probably a good time. And I will try to tag a non-good stable state that mostly builds or minimal desktop Xorg Firefox, Wayland and stuff. I will try to tag every month. If it doesn't happen, then the world doesn't go down, at least every second month, to have, for the reason to have reproducible states of, hey, you can build that, and that did build with Rust and LVM and stuff, and you can diff in between and bisect and so on. So the ugly, coming to the last part of this vlog here, the ugly is, so with Rust 167, so that 167.1 is not enough to build with LVM 16. There is at least one hotfix necessary. I pulled this change set out of Rust, so it's a very minimal one that looks to build and works, no surprise, works more stable, like it cross bootstraps, unlike 168. So far so good, but the ugly is it breaks at least Firefox, and the ugly with that is, which is kind of, I was thinking to like find a better name for this channel, and I kind of settled on code therapy maybe. They're on my code therapy here live with me on this channel, because I kind of, I started this as vlog, kind of as vlog of days of software development and stuff is broken, and it's like, even with so much work, right, testing Rust, like I probably wasted 1 hour on the latest Rust. It's not like you update it, you build it, you poke around there, shit breaks. Sure, I can go 30 minutes and feed my child stuff and then go back, and like not a whole hour wasted, but it takes a while to build and test, and then you Google a little bit around, you read a little bit in the sources, and you determine, okay, it's broken beyond repair for this moment, for me anyway, reverting that. And easily, again, like 3 hours spent on just LVM, Rust, cargo integration, testing, Googling, checking Bugzilla, GitHub issues and stuff. So the ugly here is, so even with that, so this also fails, I believe, yes, so this fails like also Rust 168.1 tweaked and patched to at least somewhat with Firefox. So that appears to be some kind of LVM regression that happens with both the last stable and current stable reads of Rust, which is some section here. Cannot represent here. Here it is already. Probably should configure less or so default to highlight errors, right? So I rebuilt that with like, and that is the stuff, right? Why do I epic thread repair with Ryzen 750X and overclocked and liquid cooled and stuff? Because I need in like 1 hour 30 or so, or 2 hours, rebuild all necessary to test stuff like this. And this does not occur with the last LVM 15001 or whatever that was, 007. Cannot represent difference across sections, could not compile gcrust due to previous error. And so this is also just compiling there. And so this is super ugly, right? Why is it ugly? I really hate this modern software. So I guess my guess is, so I also Googled that and didn't find really much on that. My guess is something with the ELF objects is whatever difference. Actually, you know what? Maybe this is actually the ELF hack now that I think about this. You know what, so the ugly with that stuff is actually, should this be the ELF hack? No, maybe it isn't. But I mean, we can try this actually. Maybe my Firefox Mozilla ELF hack only runs at the end. But so the really ugly is not only it somehow breaks, so the ugliest latest LVM breaks Rust and Firefox in some way. And that's also the stuff, right, where live here on this channel, which probably you want to share, like, and subscribe, I usually find this stuff relatively early or as one of the first, because it is just so freaking easy with our amazing, just vanilla, mostly raw scripted source distribution, probably easier than Gentoo and whatever source distribution might exist, to rebuild everything, right? Because it's just so plain text integrated and embarrassingly easy to script and stuff. And that is why, of course, the Rust people, I mean, I should not say of course. Okay, the Rust people, although I think they just pushed LVM 16 to their continuous integration stuff. But when I said of course, the Rust people didn't test like building Firefox. Although, yeah, it would be the LVM people. Although, as I said, the Rust people, according to GitHub continuous integration pull requests and stuff, they're probably switching to LVM 16 as well. So, yeah, obviously nobody of LVM and Rust fame and projects tried like to build Firefox with that. If that would be a release criterion, then obviously it wouldn't be released with that. Yeah, thinking about that, I mean, we could try, so that is, and that is also the thing, right? It takes 9 freaking minutes, so like most of Firefox build, maybe 99% of Firefox build, and that is the annoying thing, right? Especially with this, I really hate this monstrous project. I really wish Firefox would be more like, sure, it is like kind of modular, but I wish like you could build Firefox core components in 1 minute and would have 80 plugins that each built in 30 seconds of stuff, because like building like embarrassingly parallel 32 threads with all core boost of, what do we have left here? 5.4 gigahertz of stuff. 9 freaking minutes, right, until you see, cool, failed. And what I also hate, actually, we could try, so yeah, this diagnostic, there are 2 things what I really hate with this ugly state of ugly. I need to find a proper synonym for humongous projects, like embarrassingly large projects, basically. I think it's Machbuild, right? So, was it V? The problem is always, maybe it's not V. Maybe we should actually document this verbosity stuff, because even I start to forget it constantly. And so the 2 things I really hate with this modern monstrous projects is they hide like what they're doing. So you build 9 minutes, then it breaks, and then you don't even know what run. And the second is in general diagnostics, pro tip, error messages, right? There's nothing more annoying than error messages like, hey, something failed. It's like, yeah, okay, now what? Which file, what kind of, what type, what address, like sections, like which freaking, I don't even know which freaking sections, right? Text data, BSS, RO data, GNU node, whatever stuff. I believe this might even, does it do J32? What was the freaking verbose thing here? So now we need to randomly try an error. Does not accept the arguments verbose 1. Interesting. So it accepts V and what I will probably do, so how do we move forward? Of course, my time is not best spent debugging others' unsuccessful mega organizations like Mozilla's projects. So I will probably wait that out. What I will probably do is I will commit LLVM Clang to trunk, because I mean most stuff builds and then it's like more eyes, more testing, more T2 developers and users, and maybe one of those sends an amazing patch, which is probably one share, like subscribe, Patreon, GoFundMe, YouTube membership, or just play along at home and send some patches, because we love patches. And so I will commit this, otherwise my working copies already explode with hundreds of uncommitted changes, right? So I will commit those for others to test and play along at home already. This is also why did I tag yesterday 23.2.3, just to have an all good state, right? Because then I can tell users we can have, like, it wouldn't be the most amazing accepted that when trunk is broken for Firefox, which like everything probably, like famous last words of everything probably builds, but most stuff probably does. Why does this is so slow? So Rust, yeah. So maybe this is building limits, of course. So yeah, this is one Rust invocation maybe. So yeah, thank you very much for. Also, why is this load so low? And that is why it's of course better style. I mean, very theoretically we could have even stable trees, but that's a little bit too much for our small projects, maybe later. But then we can tell users, hey, check out the last stable tag and share the work of integration and testing the latest greatest LLVM Clang, Rust C and Firefox. Yeah, diagnostics. I really wish more people would follow this pro tip of more amazing diagnostics, because a memory safe language like Rust helps you a little, but at the end of the day the diagnostics still suck. Remember the holy war of compilers, of the Clang people wanting to revolutionize compilers with better diagnostics than GCC, and it's like, yeah, now we have this Rust and cannot represent a section something. Why is this load so slow though? Oh, did I apparently stop that? Does it even, is the load low, or is why does this only take 3% CPU usage? That is a little bit silly. No idea what's going on there. Is this IO limited? Yeah, I don't know. Amazing Rust performance. I mean, yeah, no, it felt like this. So this were both, some of this were both thing did not really do what, or is it, and it can't be the and yeah, so yeah, each project on build system you need to Google, and that is Mach options and how long. Or does it do something like verbose? Would it be so amazing? Hey, don't tell me this is dash dash. Hey, it's dash dash verbose. So I mean, maybe because in a previous live stream, just for this kind of, because then we would even potentially maybe even, no, maybe this, does this Python? Here's actually, wait a second, maybe this is this bloody elf hack. Because there is some Python check binary, but why is this showing Rust? Or did this check binary target? I'm a little bit puzzled whether or was it only one time? Oh no, it exists, sorry. That is an AH64 binary already. Maybe it is this bloody LFAC after all. Do we have this in CMonkey or? Where is this bloody LFAC? That we even have stuff like this. Was it not called LFAC? No, I'm puzzled. Re-enable LFAC. Let's see what this change looks like. So yeah, another pro tip, nothing to have an amazing changelog, right? Without an amazing changelog. Here is disable. So maybe I removed it in the meantime. Maybe I previously had to okay, this was commented out and then we probably later cleaned it up and removed it. So yeah, it's not the first time. The LFAC is, my understanding is kinda, it's maybe similar to this new LLVM Facebook's bolt of binary object optimization. Of rearranging code that interacts, that calls each other, so that it's more cache local, and it doesn't, like if it would be spread over the address space, then it would jump around in the address space and pollute the caches, which of course are not always, like, obviously small. So x86. Let's maybe leave it in here, so next time I don't need to search it like that. So yeah, let's see if it's the LFAC then, but probably LLVM. The question is, of course, does the binary work? If that would solve that, but so the problem is we need 9 freaking minutes, right? So you need to listen to my 9 minutes of further discussions for that. So yeah, that is the thing, right? After 1750X, you're already longing for Threadripper or Epic, an Epic or Threadripper. Strange stuff. Yeah, but so also recurring theme: do not LFAC, custom LFAC your stuff, and also like, yeah, maybe in the stuff is of course always. For Mac and Windows, it kind of makes sense, and they have 99% market share because Mozilla Firefox are building that and breathing that, so it's their stuff, so it's their LFAC of binary optimization. But Linux distributions, it would make more sense if you would have some bold, like, binary object transform optimization stuff for every binary, right? Not only like improving that for every binary, not only for Firefox. But unfortunately, Linux doesn't have 99% market share, so they custom YOLO their stuff how they need it. But I do have bolt here already. Let's put that on our growing to-do. What did I bolt? the question. So I committed that already, the other live stream. And that is binary object and layout, our layout tool. So yeah, I naturally somehow saw optimization, but of course it's not called BOLO, binary object and layout optimization. It's called BOLD, because why should it make sense? Only needs to sound cool. I wonder if you can just bold binary, or do you? Maybe it's a LLVM pass. Yeah. Nothing like googling that live here on this channel. That's doing function discovery, read debug information, read profile data, disassembly, CFG construction using LLVM table generator, disassembler, optimization pipeline. Code, so it does sample based or instrumentation based code efficiency versus runtime overhead. So that runs on a binary level. So it's a little bit like the LFAC they had, but probably more sophisticated. So it kind of sounds and it does use, so you probably need to run it. It sounds like that. So how to build in test tools. You need to record that, convert perf data to... Okay, you need to have perf data. That of course sucks a little bit. Then you can't just have a binary and also binary object and layout tool for cross builds. So yeah, more. So integration that sucks a little bit. That's a little bit like profile guided optimizations. You would need to have to run some, like if we would want to integrate that in T2, which of course we theoretically could do, but ain't the most easy. We would need to run this with perf and sample data. I just realized this this font doesn't look perfect. And it doesn't. So that's basically it for this video. The good, the bad and the ugly. Leave them in the comments below. Yeah, and basically to summarize that, after 25 years, it's somehow not getting better, right? No matter how much time and effort you put into that, something is always broken. And another case, I mean, not only that's the latest LLVM and Rust stuff was just built, but also the sheer amount of stable release changes, right? I would also argue they changed it too much, then should be in stable. In my opinion, stable should only be like real bug fixes and like security, like real mission critical bug fixes and security vulnerabilities, not like here, in my opinion, this, especially from this non-mainstream stuff, right? Why after decades do they need PowerPC 64 replace some predating E5500, never been commercialized CPU stuff? It's like, in my opinion, Linux stable would also be more amazing with just real stable, and not like, even if this would be x86, like if nobody cared for freaking decade or two, at least 15 years or so, or whatever, then don't do, like, if it was not urgent and important enough for before the final tech and stuff, then don't put it in stable, right? Also here, this is, in my opinion, totally not stable worthy, right? It only increases, what is the problem with that? It increases everyone's workload, the reviewing stuff, and because people need to review this, they have no time for more important stuff, like Sen 3 xsafe as not fixed. Previous video, and So this is also only like nice to have. Like very few people build with Clang anyway, and then like disable CPU on only like PowerPC, non-mainstream, not mission critical anymore. Disable CPU unknown for Clang, like which also very few people use, like next to nobody, like even less mission critical and PowerPC already, and it's like seriously, you had like years, and this needs to be handled in stable. I don't think so. So like fiddling around with all security mitigations, but at throttling awareness, and it's like if it's again, if this would be my kernel, obviously it isn't, but this is a little bit silly. Like basically you scroll a little bit, it's like, why is it unstable? Make sure locked. And it's like you really wonder why we still have bugs like this, right? Make machine check exception, make sure locked MCEs are processed after the service update. It's like, what's even happening? Is there a recent change? It's like, yeah, the recent change introduced, the only constant change and regressions. Merchandise, there now, merchandise store. Also, IOU ring continues to have bugs. Let target now allocated index. And this is, I'm not sure if, okay, this is a bug fix. Okay, this is stable RC. It's like, yeah, frame buffer device, incorrect page mapping clearance. It's like 2023, we still have frame buffer memory allocation glitches. Yeah. I mean, other stuff is, of course, this is a little bit funny though. This is only HPPA risk. I highly appreciate Helga Della's work. But this is super not mainstream, right? You know, like, sure, if it's, I mean, it's probably just not selecting video mode, I guess. It's fine with mode depending on the machine graphic card. So yeah, for non-mainstream and like not crashing and security vulnerability, like, I mean, I could appreciate it maybe for my HPPA risk, but yeah. Anyway, there's other, what did we have there? PowerPC set defaults. Yeah, maybe that changed something. Anyway, yeah, recurring theme. Lots of changes. 2023 MP TCP avoid setting TCP close state twice. Yeah. It's the usual monolithic Linux kernel experience. What do you mean with disappeared? Hello, you disappeared friend. What do you mean with disappeared friend? But welcome. So if you're waiting, okay, this didn't fix the thing, apparently could not compile. And so I built for ARM because I wanted to check whether the same error happened for x86. So it's not like an ARM only thing. I'm not like cherry picking the only architecture that fails. No, I'm already so much dedicated and testing. So how long did this build? 9 minutes 50, only 10 minutes of scrolling other people's bugs and features. I only did this additional efforts because I wanted to see if it only breaks for x86, but no, it doesn't. It also breaks for ARM, so maybe for all. I guess it's still the same error. So we could change in there. It's like, yeah, I probably wait some days or weeks and hope someone fixes that for me. Sometimes it happens and sometimes it doesn't. Yeah, I couldn't represent difference across sections. Also, it looks, do we have ELF? Disable ELF hack. I'm not. So if I would know what this stuff is doing, the problem is that probably rebuilds. Oh wait, we probably want to run with J1 that could potentially better show us. So it's maybe not the ELF hack after all, and this whatever is going on with. I mean, it could still be the, no, we disabled. I mean, maybe the ELF hack doesn't disable, who knows. Yeah, and with this verbosity, it's like good luck. Also, the tool's hiding that, right? Rust, Cargo and Rust hiding all the temporary or handling all the temporary objects, build artifacts and stuff, having here cryptic hashed file names and so on. It's not even that easy to review, even if I wanted. Like good luck with this modern stuff. Like previously you had like Make or other similar debuggable build systems, and you would have some objects and you would know it at the end this linker runs, but with Rust handling everything, first it generates code for 6 minutes, or it generates code for 1 minute and then tries to link it for 6 minutes. Whatever is going on here, it's a bit, yeah. That's the modern software development life. And previously, decades ago, we made fun out of Windows, of this monster that was Windows, and we had this amazing small Linux where everything just freaking worked here. I mean, now we are at the state where this open source and surrounding foundations like Mozilla and so on, they create so huge projects. Imagine how many multiple millions, not like 1 million lines of code, no, multiple millions, maybe even easily 100 million lines of code for LVM, Clang, Rust, all of Firefox that needs to work properly in synchronization and compatibility. Yeah, but anyway, I will commit the other stuff. We have tech now. I commit the working stuff. Firefox might then need some days or weeks to be buildable again. But again, if you play along at home, don't rebuild LVM, Clang, Rust, and Cargo often, right? Most people don't anyway, because if you don't have a Threadripper, it builds an hour or more. But yeah. Anyway, that's for today's vlog. Long enough anyway. Hope you enjoyed this and learned something. And why increasingly so, I mean, in general, T2 is in a super amazing state, obviously, which makes me kinda even more depressive in our code therapy session here, that I put so much, like 25 years of, sure, it doesn't have a graphical installer because I need one, I don't need one, but otherwise it's mostly amazing. And improving the installer, getting all kinds of stuff to work, and at the end of the day, latest and greatest GCC builds something, latest and greatest binutils build something, like recently PowerPC. So like, yeah, we don't get here more, even with -- verbose, right? That is, I mean, we could, this is so silly. How could developers caused by that, so at least now it's caused by running which is this? Yes, I wouldn't want a system cargo, but yeah, good luck debugging this stuff here, right? So I mean, it probably so, I mean, what probably would be a more like pro tip, which I will not do now, but a pro tip how to approach that. So it's crazy that it takes apparently 3 minutes on an 64 gigabyte. I ordered my memory, by the way. You want to share, like, subscribe, and GitHub sponsors and Patreon to fund that. Obviously, I need more than 64 gigs of memory for linking this large stuff. And theoretically, we have PowerPC to debug to actually freaking work TM, Firefox. Go fund me there. So to tackle that, I guess is this here? So is this like some kind of final link? Because so what you could probably do is analyze all those files here and diff them with 2 sandboxes. One with previous LVM 15007 or whatever that was, and compare what is generated here, right? It's probably the smartest, like, at least my smartest idea, as I'm not I'm C++ and Rust developer and patch LVM and Clang and Rust and stuff, but I'm not a Rust compiler developer, right? If you work all day long in Rust and Cargo, you probably have even more amazing than you hopefully, I mean, besides there are a million lines of code, but you otherwise hopefully know their code inside out. There was this. So the only also annoying thing is that Rust generates here this rlibs. Oh wait, there's also basic, of course, basic. So my suggestion would be, I think this is a regular AR archive, because obviously I guess it was X. So and then you would slightly wonder. Then you could analyze what's with the sections here. I'm not really sure what is this R meta thing here. It sounds a little bit metadata. Nah, amazing objects. What sections do we have? String to text, LVM BC, LVM. So it does LTO. I should do LTO, I guess. I mean, maybe it will disappear if you disable LTO potential debug. Ranges, not gonna stick. Some type. Yeah, you would need to symbol table, amazing symbols. Anyway, yeah, it's for this video. I wait this out some days and see if something fixes it magically. All the other stuff mostly works. I've still other stuff to improve. Some installer testing, other architectures, so we can. It's not like after 5 months of delays we are in a hurry to ship this instantly. But so yeah, that's the day of modern complex software development, unless you help. You get help by an AI with Copilot and whatnot. So I hope you enjoyed to learn something. Have a better day or night, and I hope to see you soon for the next fun, novel stuff. And hopefully more development to come.